Good afternoon, everyone. My name is Hannah, and I am the social media manager here at COSI. Thank you for joining me today for the 2021 COSI Science Festival. The festival has moved from a 4-day physical festival to an all-digital format May 5th through 8th. On May 8th, we hope you will connect virtually with at-home science activities and share your experience with photos or videos on social media using hashtag COSISciFest. And of course, we want to give a big shout out to all of the sponsors and partners of the COSI Science Festival, especially our visionary sponsor, Battelle. We certainly couldn't do this without them. Want to show your support for COSI? We are nominated once again for USA Today's 10 Best Science Museum. You can vote for COSI by visiting cosi.org/10best. And don't forget, COSI opens to the public on June 3rd. Now, it is my pleasure to welcome you to today's event.
Hi everyone, how's it going? I'm Laura Betts, our communications team lead for NASA's James Webb Space Telescope. We're launching this telescope this year and we're really excited to tell you more about it. Let's get started. So NASA's James Webb Space Telescope is the successor to the famous Hubble telescope. Chances are you've heard of Hubble and you've seen some of the stunning space images in books, calendars, or on clothes. This past year was Hubble's 30th birthday, and Hubble's images have really helped shape our view of the universe. We're launching this telescope this year. This image is from NASA's Goddard Space Flight Center, where I work with my team. You can see that the telescope was being assembled in the clean room there. Lots of our team is working there. So our team is responsible for telling this important story to the world, and we travel around talking to students and scientists and engineers and making sure they're informed. So why does this matter? Well, it matters because Webb is the largest telescope we've ever sent into space. It's 100 times more powerful than Hubble. It's so big that it has to fold up origami style, and it will unfold like a transformer in space. A reason why we're building this telescope is because it is much more powerful than what we have, and it's expected to cause an avalanche of discoveries. Webb's mirror is about 7 times larger than the Hubble telescope. You can see that mirror here. A telescope's sensitivity, or how much detail it can see, is directly related to that size of the mirror area that collects the light from objects being observed. So it's 6.5 meters across. A mirror this large has never before been launched into space. So for comparison, Hubble is the size of a school bus and Webb is the size of a small airplane. Webb's sunshield is the size of a tennis court and the telescope is 4 stories tall. As you can see, Webb is much larger than Hubble. Next slide. Let's play our mission overview for you.
This is your telescope, an engineering marvel, an exploration powerhouse. Use it to look back in time and explore the first galaxies that formed after the Big Bang. To peer into atmospheres of planets orbiting the stars. It's your eyepiece to the uncharted, unknown, and unimagined. This is the largest, most complex, and challenging space telescope ever constructed. It will change our understanding of the universe and our place in it. The James Webb Space Telescope. Equipped with the largest primary mirror ever to be flown in space, at 6.5 meters, it's more than 6 times the size of the Hubble Space Telescope primary mirror. Webb's 4 cutting-edge infrared instruments and cameras operate at super cold temperatures. Temperatures colder than the surface of Pluto. Getting this cold is done with the help of the largest sunshield ever flown, a 5-layer, tennis court-sized sunshield that blocks heat from the sun, Earth, and Moon. Webb will be the first telescope to detect light from the most distant galaxies in the universe. These first galaxies formed about 13.5 billion years ago, only 300 or so million years after the Big Bang. Webb carries advanced technologies to tackle some of the most fundamental questions about the universe. How did the first galaxies form and evolve? Are there chemical signatures of the building blocks of life on other worlds? Is our solar system unique?
So Webb is going 1,000,000 miles out into space, or 1.5 million kilometers away from us. So that's 4 times the distance of the moon. So one important feature about Webb is that it has a sun shield, so that blocks the light from the sun, the earth, and the moon, and keeps the telescope nice and cool. So Webb is seeing a little differently than Hubble because it's seeing an infrared light. So infrared light is light a little bit different than our eyes can see because it's radiant energy. So it's invisible to our eyes, but we can feel it as heat. So here's a picture of the cat in infrared. The cat's fur keeps her warm by trapping her body heat. Her eyes, ears, and mouth glow because of that heat. So here you can see a difference in visible light and an infrared image. So you can see inside the gas and dust clouds. So you'll be able to see some stars that weren't visible before. Webb is expected to be used by thousands of astronomers worldwide and is truly an international collaboration of NASA, the European Space Agency, and the Canadian Space Agency. Hear from some of our scientists on what Webb will learn.
One of the wonderful challenges about astronomy is that we have to imagine something so we can go look for it. But nature has this way of being even more creative than we are. So we have always been surprised by what we see in the sky. That's why building a telescope has always been interesting. Every time we build a better one, we see something we never imagined was out there. That's been going on for centuries. This is the next step in that great series of surprise us in some way that I can't tell you.
So the James Webb Space Telescope at its core is designed to answer some of the biggest questions we have in astronomy today. And these are questions that go beyond just being science questions. They're questions that really get to the heart of who we are as human beings. Questions like, where do we come from? And how do we get here? And of course the big one, are we alone?
Webb is the product of a huge international collaboration between NASA, the European Space Agency, and the Canadian Space Agency. Next slide. Webb is so huge that in order to ship it around the United States, we had to use the military's largest cargo plane, a C-5. This is the same plane that shipped Webb from Goddard Space Flight Center down to Johnson Space Center in Houston. Next slide. There in Houston, we used NASA's Chamber A, which was the same chamber used in the Apollo era, made specially for Webb this time. And after all of that testing finished up, we shipped the telescope out to Northrop Grumman in California. Next slide. There, Webb was integrated and tested, and we're doing some of the final checks before we finish up testing, and we'll be shipping it to its launch site in French Guiana. Next slide. So we're launching from ESA's launch site in French Guiana, in Kourou, and Webb is so big it needs to be folded up to fit inside that rocket. Next slide. And then can play this. Once it heads out into space, it'll start its 2-week series of deployments. So this is a very crucial step for our engineers and scientists, where everyone will be waiting with bated breath to see how this goes. They're doing all of this testing to make sure this is going to be going right. You can see the parts of the telescope start to unfold here. You can check out this video on our website. Watch it in more detail. There's lots of activities for you to do at home about this telescope. We've got language cards, coloring activities, star cycle bookmarks, models, fun pads. We have an invitation for you to send us your art If you're inspired, you look at our telescope, check out our website, tag your art with hashtag JWSTArt. We are collecting and sharing art from all over the world. So please use your imaginations if you're so inclined, and we would love to see what you come up with. Next slide. Here's all of our websites and social media. So if you want to get in touch with us for any questions at all, please do. We are answering them all the time. And thanks so much for your attention today. We hope you keep learning and exploring and learning so much more about NASA's James Webb Space Telescope. Take care. Have a good day. And if you have any questions, please definitely let us know, and we'll be happy to answer them for you. So you can reach out to us at NASA Web as our hashtag on all of our social media. Okay, question: what advice do you have for people, especially women and girls, interested in this field? There are some of the most incredible women engineers and scientists working on this project. So if you want to work in science, you want to work in engineering, you want to be in media, go for it. You can do anything you want, and just make sure that you're talking to good mentors. So you can reach out to us, and if you're interested in talking to scientists or engineers about their backgrounds, don't hesitate, because we're always doing lots of programs with schools and making sure that everyone has opportunities to learn more about how they can get into this kind of field. Will astronauts be able to service this telescope like Hubble? Part of the reason why this Webb telescope is so important to get all the testing right on Earth is because it's not going to be serviced like Hubble. It's going 1 million miles out into space. So that's why they're doing all of this testing here on Earth, to ensure that that incredible deployment sequence goes exactly as it's supposed to out in space. There's another question came in. What is the size of the team that works on this mission? The team that works on this mission is very large, and it has teammates from all over the world. So there's not only the team that is working on the telescope itself, but then there's all of the scientists all around the world who are going to be using the science that comes back from this telescope. And that's what we're most looking forward to. So we have a very big team all over the world who's clamoring for this information. Another question from Joey: what did you study for what I do? So I am our communications team lead at NASA, so for the James Webb Space Telescope at Goddard. And I studied journalism and had a lot of concentration in science classes, because I just think that this science is so interesting, and it's just a really cool way to keep learning and discovering. And I think that exploration is such an important part of what makes us up as humans. So what better place to work for than NASA? Got another question from Valerie. Thank you for your question. What questions do scientists wish to answer with the Webb telescope? It's a great question. We hope to learn so much from the Webb telescope, and our scientists like to say that we haven't even really begun to ask the questions that the Webb telescope is going to help us answer. There are so many interesting topics that we'll be learning about. One of the crucial ones that infrared telescope is going to enable us to do is to be able to peer through the gas and dust clouds to see what's happening with a lot of formations. So we want to learn about stars and galaxies as they're forming. We want to learn more about exoplanets and really build on a lot of the knowledge that we've learned from the Hubble telescope. Any other questions? What different types of backgrounds do scientists have working on this? So many different types of backgrounds. So if you are interested in any area of science, really, there's so many people on our team who've studied different things. We have scientists who've studied physics, astronomy. There's a lot of scientists who even studied chemistry, especially if they're working with exoplanets, because one of the unique things that we're learning from this telescope is there's all these different instruments, they're essentially cameras on the telescope, that are going to enable us to do different things and learn about different types of science. And you're going to be able to tease out some of the chemical compositions from different exoplanets. So there's a lot of fascinating different elements of science that are involved with this telescope. Next question from Jenna. So what's next after the telescope launches? Is NASA developing others? Yes, so there's many more telescopes that are in NASA's queue because there's so much more we can learn about the universe and what's out there. So NASA's Roman telescope is another one you can read about. So be sure to check out that one that's in development online if you want to check out some of those stories. It's another fascinating telescope coming down, and it's actually named after Nancy Roman, who is known as the mother of Hubble and was in one of my pictures earlier on in the presentation. She's a fantastic woman who is spearheading her field and really helped make a difference. Do you work on any other NASA missions? Right now I'm working primarily on the Webb telescope, but there's so many interesting NASA missions, and used to work in Earth science for another wonderful satellite mission. So there's so much that NASA is learning and discovering about. So definitely check out a lot of the other missions because there's just so much that we're doing right now to learn about different parts of the world and about the universe. Another question came in. How does this telescope help us here on Earth, and why is it important? Well, anytime we embark on a new project like this, there's so much technology that comes back. There's so much spin-off technology that comes through. So just in order to design this telescope, there were 10 different basically inventions that needed to occur. So there's 10 different types of technology that came about as a result of this telescope. And one of the wonderful things that's really cool to me, especially being someone who, doesn't have the best eyesight, was that this telescope some of the technology helped to make LASIK eye surgery better. So that's just one example of what this telescope has brought to us here on Earth, even before it left the ground. Another question from Michael. How is math used at NASA? Math is used all the time. So if you're interested in math, then NASA would probably be a wonderful place for you to work. So a lot of our engineers and scientists need to use math to plan out all of these massive builds. They need to use math to figure out exactly how they have to make sure a test here on Earth is going to be the right test to get something out into space. And think about just how far we have to send this telescope. There need to be all sorts of math just to get it to that point in space. The place we're sending the telescope out in space is at a Lagrange point. And those are special points out in space. That's a huge, development. It's a huge, interesting facet of this telescope. And if you read about it, that's like a really fun math fact, because there's these special places out in space that are great to send to telescopes. Can you talk about non-traditional career paths that could lead to a job at NASA? Absolutely. So there are so many different backgrounds at NASA. We have so many different people that work at NASA who, some people, if you look at our telescope, you'll see that there's this massive sun shield at the bottom of it. And there's space blanketing at NASA. So we have seamstresses that work at NASA. You have engineers, scientists, accountants, lawyers. Think of any position or any background, and those are some of the folks who work at NASA. If you just have a desire to explore or to learn, pretty much there is a role for you at NASA. It's just such a wonderful place to work, and there are so many cool backgrounds. The best part about learning and working at NASA for me is that we all work together as a team. So it doesn't matter what your background is, you have a valuable insight to add to this story, and you're going to be able to contribute. So that's one of the most wonderful parts. Any other questions? How is the launch location chosen? That is a fascinating question. So the launch location was chosen because this isn't just NASA working on this project. This is a huge international endeavor. So the European Space Agency is a major contributor, as well as the Canadian Space Agency. So ESA's launch site is in Kourou. So that's their Arianespace spaceport. So that's why we chose to go out there. It's because not only is ESA going to provide the launch site, but they're also providing the rocket. So we're launching on an Ariane 5 rocket, which is one of the most reliable rockets. And it's one of the largest rockets because we are so big. We're bigger than any space telescope ever sent out into space. So we have to fold up like origami and then open out in space like a transformer. So if you look on our website, we have a ton of activities that are really fun to show you how to build a telescope yourself. So if you want to check out some of those origami activities, we have those available for you, as well as a lot of different models. So you can look at all the different components of this telescope on your own and build a telescope yourself to check it out. Any other questions? Okay, well, thank you so much for all of your great questions. Please don't hesitate to reach out to us with any other questions you might have, and be sure to check out our website at just.nasa.gov and at NASA Web on all of our social media channels. So thanks again, and have a good rest of your day. Take care all.